We are going to address the Pythagorean theorem and its inverse or converse, depending on how you look at it and how you consider this. Pythagorean theorem, remember, is not a squared plus b squared equals c squared. Those are just letters and variables that represent certain things. That isn't how it is defined. The Pythagorean theorem is defined as if we have a right triangle, the sum of the squares of the length of its legs is equal to the square of the length of its hypotenuse. In other words, you need to be able to recognize that your hypotenuse is across from your 90-degree angle. And that your other two sides are just considered legs. So it's not a squared plus b squared equals c squared. It's leg squared plus leg squared equals hypotenuse squared. And it matters, because if we just memorize a squared plus b squared plus c squared, we will oftentimes not recognize that that's only true if we consider c, the side length, as my hypotenuse. And you have to remember both. In addition, the inverse or the converse allows us to make decisions by checking this equation and comparing the length of my hypotenuse, or in other words, the length of my longest side, to the length of my two shorter sides squared and added together, the sum of the legs of my triangle. I can decide if my triangle is right, acute, or obtuse. Now, the order here matters. I do want to check the longest side first. So when I have a list of side lengths, I'm going to pick the longest side length, square it, then take my other two side lengths that are shortest and middle, or the two shorter side lengths, square them and add them together. If the value here is equal, if the longest side is equal to the sum of these two sides squared, that guarantees that I have a right triangle. That is the definition of the Pythagorean theorem. But what if it's not equal? Well, now I have to decide. If it's bigger, so this symbol means the longest side is greater than the shortest side squared plus the middle side squared. So the longest side squared is greater. That means really long. And remember, the bigger your side length is, then the bigger the angle across. So if it's equal, my angle across is 90. If it's bigger than 90, or obtuse. That makes this an obtuse triangle. And then less than means it's less than my 90, or an acute triangle. Now let's get some practice. If I'm simply trying to find a side length, that's the exact application of Pythagorean theorem. But you're going to need to simplify square roots or simplify radicals. I'm not going to want decimal answers here. So if it's not a perfect square and you have a square root and get a decimal, I want you to simplify that. If you don't remember how to do that, there is a video in Canvas. There's actually 2 videos in Canvas. You can look it up on Khan Academy. You can find any resources you have, including coming in to see me and going over it. But let's take a look at our application. Since this is my right angle opposite, makes this side my hypotenuse, my Pythagorean theorem states that my leg squared plus leg squared equals hypotenuse squared, or 6 squared plus 10 squared equals x squared. Okay, through the magic of algebra, I'm going to do this in a couple of quicker steps. 6 squared plus 10 squared is 136. That's equal to x squared. Now, square root both sides to get x by itself. Square root of 136 is not a perfect square. So this is where I have to start simplifying my radical. Those are our factor trees. You're pulling out pairs. If you don't know how to do that, please watch the videos and or come in to see me. But what we get when we simplify this square root is 2 square root of 34. That's the side length of my hypotenuse in this problem. That's how I would expect us to answer that question, not with a decimal. Number 2 is a little bit different because my right angle is here, x is here. X is actually a leg. 18 is my hypotenuse. So it's not always number squared plus number squared equals variable squared. It's always leg squared plus leg squared equals hypotenuse squared. In this case, x is a leg, so it's x squared. Plus 14 squared equals 18 squared. Leg squared plus leg squared equals hypotenuse squared. Again, the magic of algebra would allow me to get to x squared equals 18 squared, and then subtract 14 squared from that. I get 128. Just like before, I square root both sides to get rid of my exponent and leave me with just x. Just like before, this is not a perfect square. You are expected to simplify that. If you want practice with it, go ahead and pause, simplify your radical. In a couple of seconds, I'm going to put the correct answer up. And we do get 8 square roots of 2 when we simplify that radical. So those are really our two major options when we're applying the direct application of Pythagorean theorem. But what if I'm asked to classify a triangle by its angles, and all I've been given are side lengths? That's where we use the opposite of our Pythagorean theorem, where I need to compare my longest side squared to my two other sides, so I'll call it short and middle in this case, added together, short squared plus middle squared. Well, my longest side here is not 20, it's not 99, it's 101. I need to square that. And then compare it to 20 squared plus 99 squared. 101 squared is 10,201. 20 squared plus 99 squared, using our calculators, is 10,201. Now I compare these. Looking back at my diagram, these two are equal. That makes it a right triangle. By definition, because these are equal, I can conclude that the triangle with these three side lengths is a right triangle. I could say that 20, 99, and 101 are a Pythagorean triple. They represent the Pythagorean theorem, and they are all integers. Our last example here is similar. I have to compare my longest side to my short side plus my middle side. Now my long side is 12. Don't just go in order. Make sure you pick the biggest number. I'm going to compare 12 squared to 7 squared plus 10 squared. So I'm comparing 144 to 149. Now, 144 is less than 149. If these two are equal, it's a right triangle. But if this side, my longest side, is less than that, so if they're equal, it's 90. If it's less than 90. This, my longest side being smaller than my other two sides combined, as far as their squares, that makes it an acute triangle. There will be a practice quiz on Canvas. There are additional videos, and you can always come in and review material with me.